So here's one for you. We have a couple of different outcomes. In the summertime, especially, you can see these differences when there's a lot of solar radiation. But on the left, we can actually have warmer temperatures at the surface because of the clouds, not because, in spite of them. Whereas in the one on the right, the clouds do result in cooler temperatures than it was if it were perfectly sunny. What's the difference? If you look at the two diagrams on the left and on the right, you see an obvious difference. The one on the left, you have these thin, wispy cirrus clouds, and you might recall from the albedo slide that some clouds don't really reflect very much radiation back. And so these clouds in this one on the left, most of that radiation is getting in. A little bit's reflecting back, but most makes it in. But what it does do to a large degree is it does manage to absorb and re-radiate the long-wave infrared radiation from Earth. So while on one hand you get a little less sun, the heat that does get absorbed, or the solar radiation that gets absorbed the ground warms up the ground, and then the ground is sending out that long-wave radiation. That radiation, very large parts of that get trapped, and so much more so than what we would get on a clear day. So we simply have what we call net greenhouse forcing and warming. Amazingly, a high thin deck of, or a high thin cirrus cloud movement over an area in the summer on a hot day can make it even hotter. Now, the other example is common in the Willamette Valley in the summer. You'll get this kind of stratus cloud stuff come in. They're fairly thick sometimes. And when they're that thick, it might take the sun a long time to warm up the ground enough to break the clouds cover out. So we have a net cooling effect from that as we're losing a lot of the total solar radiation due to reflection. While at the same time we're trapping pretty effectively the radiation that does make it to the ground and then re-radiates back as long wave radiation. It's not enough to be as warm as it would be in the one on the left or even on a sunny day.